Hey again, guys. We're just going to pick up right where we left off before with our area is actually just base times height for my ith rectangle, where I is representing every rectangle under the curve. So if we start with our first rectangle, add our second rectangle, 3, I is 4, I is 5, all the way to n, we add up all those rectangles, and as long as we can do an infinite number of them by taking that limit, we will get our exact area. If we just stop at 20, well, it's probably good, but not as good as it could be. If we stop at 2,000, well, it's pretty good, but not as good as it could be. It's best when we take n going to infinity. So now the hard part is figuring out what delta x is and what f of x sub I is, and then figuring out how to even apply that whole thing. Well, we came up with delta x before, actually. If you look back at the other video, we came up with delta x was our play area, b minus a, right, from 0 to 5 or whatever, and divided by the number of rectangles we have. That's b minus a over n. X sub I is a little bit trickier to kind of figure out. Okay, x sub I is a little bit trickier because we don't know where x sub I is actually located, right? If I pull this back in to the picture, here's x sub I, but I don't know how far away it is. How far away from the origin is x sub I? Well, is it this far away? Because that would just be delta x. Is it this far away? Well, that would just be 2 delta x's. Or maybe it's 3 delta x's. Or 4. Well, every rectangle is a delta x. How many delta x's before I get to my ith rectangle? I delta x's. And the only other thing you got to account for is that in this case we're starting at 0 for that example, but we always start at a. So if I go back here, I start at a, and I go I delta x's away. Okay, let's look at that again. Start at a, okay, that's no big deal. What if it was just, one rectangle away? What if I was 1? Well, then it's just delta x. That's where my x sub I would be. What if it was 2 rectangles away? What if x sub 2 was really my ith rectangle? Well, that would be delta x and delta x. That's 2 delta x's, or 3 delta x's, 4, etc., again, until my ith rectangle, which is I number of delta x's plus a, wherever you start from. Again, this example was 0, but it could start from anywhere. So my x sub I is physically located at my starting value plus however many rectangles I've got times delta x, which is the base of each rectangle. And there's my x sub I. So f of x sub I won't be so difficult. You literally just plug in x sub I into your f, and you go from there. So like in our example, if we really want to do f of x equaling x squared from 0 to 5, we can actually now figure that out. F of x sub I would simply be a plus I delta x squared for that particular example. Okay, but since that is a specific one, why not let's just substitute everything we know, right? Delta x we can now isolate a little bit more. So my delta x for this example would be 5 minus 0 over n, which is 5 over n. Okay? My x sub I starts at 0, right, plus I times 5 over n. That's delta x, which is just I times 5 over n. Obviously, the 0 doesn't really matter. So my f of x sub I is going to be I 5 over n squared. I have f of x sub I. I have delta x. That's exactly what I need in my area formula. So now I can actually go ahead and substitute. So area is going to be the limit as n goes to infinity of my sigma notation of f of x sub I, which is basically 25 over n squared I squared times 5 over n, right? Delta x, f of x sub I, and there's my two pieces. Clean that up. I'm just going to go to a new page. Clean that up a little bit. So my area is going to be my limit as n goes to infinity. Limit as n goes to infinity of 1 to n. And I've got, of course now I forgot what it was. It was 25 over n squared I squared. So 25 times 5 is 125. So 125 over n cubed, feel free to pause and go rewind if you need to, times I squared. Okay, and that's where we leave off for the simplified version. Now, we still don't know how to deal with all this yet, but I can tell you this. N is a number. Whether it's 2, 200, 2,000, 2 million, 2 billion, it's still just a number. So 125 over n cubed is just some number. So I'm just going to factor that out. I still have to deal with the limit. I can't take care of that yet. But I'm going to factor out the 125 over n cubed and then times my sigma notation from 1 to n for I squared. And this is the moment where you look at this sigma for I squared and you say, oh, that's right. He gave us that little cheat sheet that has those formulas on it. So if you refer to your cheat sheet, we should have a way to deal with the I squared. So let's see. That one is going to be n times n plus 1 times 2n plus 1 all over 6. And that takes care of I squared. There's a pattern for that, and if you're welcome to look that up if you need to, but we're just going to have to use that pattern for now whenever it becomes, available to us. We'll do a little algebra switcherooski. So let's take the 125 and put it over 6 times, this becomes 2n cubed plus 3n squared plus, what's that, just n? All over n cubed. 125 over 6 has nothing to do with n. So that 125 over 6 is just some number. So I'm going to actually pull that out of my limit because it has no effect on it. The limit has no effect on that number. 2n cubed plus 3n squared plus n over n cubed. Now this is where you got to sort of say to yourself, wait, I've seen something like this before. We've done many problems like this where you have the powers the same and you just kind of end up looking at those leading coefficients. If the denominator's power was bigger, well, then this would just go to 0, which doesn't make a very good area problem. If the numerator was bigger, well, it doesn't make a good area problem either because then you'd have infinite area. So this is going to happen pretty much every time. And if it doesn't, then you know something probably went wrong. So the limit as n goes to infinity for this is just 2. So my area is 125 over 6 times 2, which is 125 over 3, which is 41 2/3, which a lot of you figured out using the dark side the other day. But this is the actual area. Okay? I'm going to do another example so you can kind of see how things work as well, but hopefully this was a good sort of review for you. You kind of go back and look over all the steps. Some of the trickier parts, here, pulling out the 125 over n cubed. Remember, it's just a number. I'm just factoring it out. Another tricky move was just using the formula, which is right here. Some people don't like when I switch the denominators, but it's just the commutative property. You could multiply this all through if you want and then refactor it back out, but there's no need to. And you end up getting your area. And notice, you dark side people, we didn't use any antiderivatives here. We found this area using only rectangles, only limit, and essentially just did base times height. Okay? Let me know if you have any questions. This should get most of you over the hump, but let me know if you have any questions. I'd be happy to help you out. Okay? I'll talk to you soon. Bye.